The binomial formula itself can seem pretty daunting. It's in the two boxes below. But let's make sure that we understand the three parts of the formula and understand that there are three parts of the formula. So the first part of the formula is made up of the number of ways x can happen. So that's what we just found a few minutes ago, the combination piece of it. So, there's three questions on a test. How many different ways could only one of them be right? Three ways. It could have been the first, the second, or the third. So that's part of the formula. The next piece of the formula is the probability of one success x times. So in this case, the probability on a true-false question is a half, and we want it to happen one time. So that's going to be the middle part of our formula, where all of these parts are being multiplied. And the last part of the formula is the probability of one failure the rest of the time. So in this case, two questions being wrong, where there was a 1/2 chance of them being wrong since it was a true-false question. So the formula is listed below, where I use the factorial notation and I use the combination notation, since that's probably what you're more likely going to be using. The thing to recognize is that first piece that I wrote in purple, the number of ways x can happen, is the first part of the formula, whether you write it out as a factorial or you use your combination button. Then the next part, the probability of one success x times, that middle part is we take that success to the x power, because that's how we get repeated multiplication. That gives us the number of times. And so our last part, which is q, the probability of a failure, the rest of the time is the last multiple piece of the formula. Now notice it says n minus x, because n minus x is the rest of the time. That if you're doing something 10 times and 2 of those times you want success, then 8, which is 10 minus 2, 8 times would be the failure. Again, remember, I'm not expecting you to do the binomial by hand. Some of you can do the whole problem at once in your calculator, either because your calculator has a binomial button or because you're doing the three parts. But the biggest thing to remember is if you're going to do it one part at a time, do not round each part. So now we're ready to actually solve some problems using the binomial problem. As I read the question, the probability that exactly 10 flights arrive on time out of 15 flights, if there is an 80% on time rate, fits my 4 criteria. I still like to know what's success, and in this case, success is a flight that's on time. I need to find n, my fixed number of trials. We're looking at 15 flights. X, the number of those items I want to satisfy success. 10. X is 10 flights on time. P, the probability of success, 80%, but remember we'll use the decimal form of 0.8. And so Q is the probability of failure, which is the complement of success. So we're going to get 0.2. 20% of flights are not on time. Remembering that the formula is starting with 3 parts, I want the probability of X, the probability of 10 flights on time. So I find how many different ways can that happen. So I use the combination button, NCR or NCX in reality. The next thing I want to do is the probability of success that many times. One success happens 80% of the time, and I want 10 of those flights to be on time. So I'll take it to the 10th power. Now I want the probability of failure the rest of the time. Since there's a 0.2 chance of a flight not being on time, 5 of our 15 flights won't be on time, right? 15 minus the 10 that were on time leaves me 5 that weren't on time. So I'm not able to use the binomial distribution button on my calculator, so I have to do it in parts. I use the NCR part to get 3003. I take 0.8 to the 10th power, and I get a number that goes off the edge of my calculator. So always write at least 5 digits down, but if you could write all of them, that would be even better. When I take 0.2 to the 5th power, I end up with 5 digits and then it stops on my calculator, so definitely use all those digits. Now, one of the things I'll do sometimes is I'll actually go back and do 10 to the 8th and leave the long number on my calculator and hit times 3003 times 0.00032. But when I do this, I get 0.10318. In this case, the directions don't say it, but I'd like you to answer as a percentage with one place to the right of the decimal and that would end up being 10.3% after rounding. So my final answer is 10.3%. This means if there's 15 flights we're looking at with an 80% arrival on time probability, the chance that of those 15, 10 that we randomly grab, just 10 of the 15 that were on time, there's only a 10% chance that 15 of them, 10, I'm out of control, were on time. Here's another problem. Question 2. 2% of all watches shipped have a defect. What is the probability of finding 2 defects in a shipment of 50 watches? Now remember, the probability that we're looking for success may not be a good thing. In this case, success is a defective watch. I don't want a defective watch, but that's what we're looking for. My fixed number of trials, 50 watches. How many of those do we want to be successful, or in this case defective? 2. What's the probability any single watch is defective? 0.02, be careful, don't forget 2% is 0.02 because we need to move the decimal 2 places to the left. So that means Q, the probability of failure, although in this case that means a watch that works, would be 98% or 0.98 because it's the complement. So as I plug the parts into the formula, the probability of 2 defective watches is the number of ways it can happen, so my NCR button using 50 and 2. The probability of 1 success to the x power, so 0.02 to the second power, and the probability of failure to the n minus x power, or in this case, 0.98 is the probability of a single failure, and I happen to want 48 of those to be working, which in this case is a failure, because notice 50 minus 2 is 48. Hopefully my 4 doesn't look like a 9. I plug the parts into my calculator to get 1,225 for the number of different ways I could line those watches up where 2 of them don't work. 0.004, and it stopped, ways of success, and 0.379185 ways of failure, and it probably kept going on my calculator. It did, but I forgot to put my ... As I multiplied everything together, I get 0.1858, which gives me a rounded 18.6%. Don't forget that when you go to round, I'm looking at the number after my cutoff point, and because that 8 was a 5 or larger, the 5 that I underlined rounds up to a 6. And so I place my answer in my answer box that there is an 18.6% chance that 2 watches would be defective.